Hi, my name is Kamal, and today we are going to start this video with talking about multi-threading applications in C Sharp. If your application needs to execute multiple tasks concurrently, for example, a game application that simulates car racing, then you need to use the multi-threading techniques in .NET. So what is a thread? A thread is a flow of control with an executing application. And in C Sharp, any application will have at least one thread, and that thread known as the main thread, which executes the application itself. But you as a developer, you can create multiple threads spawning the main thread to concurrently process tasks of your application. So to use the techniques of the multi-threading in .NET, you have to use the namespace system.threading, which contains classes and interfaces that provides built-in support to multi-threaded applications. So now let's see the idea of the multi-threaded applications in action. In a simple threaded application, which is working just with the main thread, commands will be executed sequentially, one after another. As we will see in this example here, we have the method print, which dumps numbers from 0 to 9 in the console. And then we have a for loop, which dumps capital A 10 times in the console. So we invoked print firstly, and then iterating 10 times to dump capital A. So this application will be treating these commands sequentially, finishing the execution of the print method first, and then jumps to the for loop to dump the capital A. Let's see the execution of the code. Look, numbers from 0 to 9 and then a 10 times. If you executed these applications million times, uh, the flow of the execution of commands will remain the same. There is no chance to be changed because we using a single threaded application. Now let us convert our previous example to a multi-threaded example. So I will delete this code. The for loop will remain as it is. Here I will create a thread. To create a thread, I have to use class thread, which is belong to namespace system.threading. So I will create object of thread t1 equal new. I have to instantiate this object. The instantiation of this object is going to be through the constructor of the class thread. The constructor of the class thread has 4 overloads. One of the overloads is receiving an object of thread start delegate. A thread start delegate that represents the methods to be invoked when this thread begins executing. So here I will pass an object of thread start, and the thread start object will point to a method. This method is going to be our print method. Look, our delegate is pointing to a method. As we know in the previous sessions that the thread is a pointer to a method that is going to be executed when we call the thread or when we invoke the thread. So to start the thread, we are going to use the method start of the object thread t.start. Now our thread is started. So This is all. Our application is converted to a multi-threaded application, and this code is not going to be treated sequentially by the CPU. CPU will deal with this application as a multi-threaded application, consists of the main thread here and T1 thread here, and this thread is going to be executed concurrently. When I say executed concurrently, that is mean CPU maybe choose this to start its execution and then suspend it and give a chance to T1 to start its execution and suspend it, and then get back to the main thread and suspend it until they complete their tasks. Okay, let's see the execution of the code. Look here, CPU started the main thread and then suspends it, and then started the T1 thread and completed the thread to the end, and then resume the main thread and completes it. If I execute it for a second time, okay, this is the same, started with the main thread. For third time, okay, fourth time, let's see, fourth time, okay, look, double A, numbers from 0 to 9, and then completes the execution. A first time, A only 1, and then numbers, and then completion of the tasks of the main thread. This is a simple way of dealing with multi-threaded applications in C#. So thread class constructor has many overloads. In our previous example, we've just seen a constructor which is accept a thread start delegate as a parameter, and as I mentioned earlier, thread start is representing a method that is returning a void and accept no no arguments. This is the method that is represented. This is kind of the method that is represented by thread start delegate. If you need to pass a parameter to your thread, then you need a method which is accepting parameter as object. Here we created a method called test, which is accepting parameter as object. So to use this method with a thread, I have created thread 2, and thread 2 constructor is accepting a delegate named parameterize thread start. Instead of thread start, we will use parameterize thread start. This delegate is representing a method that is accepting an argument of type object. Any method accepting an argument as an object is going to be passed to this delegate, and this delegate is passed to thread. And then when you start your thread, you have to pass the value of this object to the method that is going to be executed. Second or third type of using the constructor of the delegate, you can pass, instead of passing a thread start or parameterized thread start, you can pass a lambda expression, and the lambda expression is going to be converted to appropriate delegate. Look here, thread ts3 equal new thread lambda expression accepting object parameter, and then console dot write line do something, and then object dot to string. Okay, this lambda expression is going to be converted to a parameterized thread start delegate, because here we use the lambda expression which is accepting an object as a parameter. This is like using a test. If you want the compiler of C# to convert this delegate to a thread start delegate, then you have to delete this parameter, and it's okay. It's okay. uh, Here the lambda expression is going to be converted to a thread start delegate, because it is a method without an argument. Okay, here we are passing nothing, because our delegate is accepting nothing. If I executed this application, our delegate is going to be started. We have four delegate here. T1, sorry, we have four threads, T1, T2, and T3, and the main thread represented by a for loop. So our final example is going to be a simple game, which is represented by a method called play, and this method is accepting an argument of type object. This object is a player. I have created a class called player info, which is consists of a field as a static field with type boolean, with the default value false, and then the name of the player. We will pass this information to the play method. The play method is accepting an object. This is just an object. You can pass integer, string, double, and so on. So the object that is passed here, it must be cast to the appropriate type. It must be casting or converted to appropriate type. So here I did a symbol type casting. The object of the player must be converted to the object of type player info, and stored in a p object. Any player must start from the start line, which is 0, integer c equal 0, and the player is going to be a winner of the game if he reaches the finish line. The finish line is 500. So here I will increase the counter C with 1, and then console dot write p dot name. Here I just dump the name of the player on the screen, and then I will check if C reaches 500, then the player is going to be titled as the winner, and player info.win is converted to a true. If the player is a winner, then I will break the thread. Okay, now this is our play method. So I will create 4 players in the main method here. This is the first player, which is thread t1 equal new thread, and to instantiate this object, I have passed to the constructor of the class thread, I have passed a parameterized thread start. So the parameterized thread start must point to a method with only one argument as an object. Okay? Here is the play method. So my threads are identical. This is player 1, player 2, and player 3, and the fourth player is the main. Okay, they are identical. They are always start from the start line, which is 0, and have to run until reaches the finish line, which is 500. So when I started my first thread, I will pass an object of a player info. T1.start new player info. The first player called A, and the second player called B, and the third player called C, and the last player is the main thread. Here I have just called or invoked the method play, and passed an object of play info, and the name is M. So when I start this application, when I execute this application, I have to see the winner. Okay, here the winner is A. This is the winner of the game. If I execute it for the second time, the winner is A. Sometimes two players can reach the line at the same time. A and C reaches 500 at the same time, so A wins and C wins. And if I execute it here, B wins. Executed the last time. Okay, A wins. This is our last example. I hope this video is going to be useful for you. If you like this video, please like and subscribe. Thank you so much for your patience.